I'm Brad Hanson. I'm a professor here in the astronomy department. I mostly work on exoplanets. I do some work on stellar structure as well, and I started in stellar structure, but with the discovery of the planets, various kinds, it was a very natural thing to evolve into studying exoplanets. I work on a variety of subjects. One of the things we've been doing is studying the assembly of planetary systems under various conditions, and in particular trying to match some of these observations of planetary systems around Kepler stars. Kepler is a NASA satellite that was launched a few years ago, and it's essentially a satellite that searches for transiting planets. So what they do is they use the telescope and stare at a field of stars as continuously as they can, given various requirements having to send their information back to Earth. But the idea is essentially monitor millions of stars continuously and monitor their brightness especially, in order to sort of see small dips and small periodic dips which tell you that a planet has passed in front of it. So if you have just a random collection of planets, only a very small fraction are going to be aligned directly such that they actually pass in front of the star along the line of sight between you and the star. So you have to look at many, many stars in order to do this. But the payoff when you do that is that you not only get an idea of the period of the star, you also get an idea of the physical size of the star. And then you can also go and you can take spectra of that star and look at the motion of that star around the center of mass of the system. And that gives you the mass of the planet. So you can get an idea of both the physical radius of the planet and the mass of the planet. And so you can start to test ideas about what the structure of the planet actually is. Is it a gas giant, or is it a rocky Earth mass type of planet, or something in between? I would say our system is common in the sense that it has gas giant planets and Earth-like planets. So in that sense it's common, because roughly 50% of stars now, it seems, have some sort of system. Now, it's perhaps a little less common as to the actual configuration of planets. And so if you start asking how massive are our planets, how close to the stars, how far away from the star, then it's not so clear how common we are. One of the interesting things in our solar system is that most of the mass in the inner solar system is in Earth and Venus. Mercury and Mars are 10% or less of the mass of Venus and Earth. And so why is the mass in our inner solar system sort of narrowly constrained in a fairly limited range of separations, whereas some of these other systems, it can range over an AU in scale. You can have several planets. So that's one of the things we're trying to understand, and sort of seeing what initial conditions give rise to which configurations.